Hello everyone and welcome to our YouTube channel. Today we are going to talk about one of the most intriguing experiments in the field of quantum mechanics, the quantum eraser experiment. In this video, we will explain the experiment in detail, how it works, and what it tells us about the fundamental nature of reality. So, let's get started. The experiment. The quantum eraser experiment is a thought experiment that was first proposed by John Wheeler in 1978, and later realized in 1982 by Marlon Scully and his colleagues. The experiment is designed to investigate the wave-particle duality of light and how it behaves in the presence of measurement. The experiment begins with a laser that emits photons through a crystal that splits each photon into two entangled photons. One of the photons is sent through a prism, which causes it to travel along two different paths, labeled Path A and Path B. The other photon is sent through a beam splitter, which sends it down two separate paths, labeled Path C and Path D. Both paths C and D are blocked by detectors, so the photon can only travel down one path or the other. However, because the two photons are entangled, the path that the photon on Path A takes is correlated with the path of the photon on Path C, and the same for the photon on Path B and the photon on Path D. At this point, we can say that the photon on Path A has been measured, because we know which path it took. The photon on Path B, however, has not been measured, and we don't know which path it took. This is where the eraser part of the experiment comes in. If we place a detector at the end of Path B, we can determine which path the photon took, and the wave-like interference pattern will disappear. However, if we remove the detector at Path B and instead place a detector at Path C or D, we can determine which path the photon on Path A took, but the interference pattern will reappear. Theory. So, what does this all mean? The experiment seems to suggest that the act of measurement itself affects the behavior of the photons. When we measure the photon on Path A, we know which path it took, and therefore it behaves like a particle. However, when we don't measure it, it behaves like a wave and interferes with itself. But how can the act of measurement affect the behavior of the photon on Path B, which is entangled with the photon on Path A? According to quantum mechanics, the entangled photons are in a superposition of states until one of them is measured, at which point the wave function collapses and both photons decide on a definite state. This means that the act of measurement on one photon can affect the behavior of the other photon, even if they are separated by a great distance. This is known as non-locality, and it is one of the most counterintuitive aspects of quantum mechanics. Conclusion. In conclusion, the quantum eraser experiment is a fascinating demonstration of the wave-particle duality of light and the strange behavior of quantum systems in the presence of measurement. It challenges our understanding of the fundamental nature of reality and forces us to confront the weirdness of the quantum world. We hope you enjoyed this video and learned something new about the fascinating world of quantum mechanics. Thanks for watching. Please don't forget like, share and subscribe and press the bell icon.